Now, what about for Gauss-Jordan elimination? What makes this different from Gaussian elimination? With Gaussian elimination, you apply elementary row operation to a matrix to obtain a row equivalent row echelon form. A second method of elimination, called Gauss-Jordan elimination after Carl Friedrich Gauss and Wilhelm Jordan, continues the reduction process until a reduced row echelon form is obtained. Example, use Gauss-Jordan elimination to solve the system is actually the same thing as the problem that we had earlier. So using the same problem, x minus 2y plus 3z equals 9, negative x plus 3y equals negative 4, 2x minus 5y plus 5z is equivalent to 17. We know that the Gauss-Jordan elimination is just a continuation of the Gaussian elimination. We will already have the row echelon form from the previous problem, which is given by 1, 0, 0, negative 2, 1, 0, 3, 3, 1, and 9, 5, 2. Now, to find the reduced row echelon form of this matrix, we have to perform what you call a backward process. So here we need to convert, okay, since already have the leading ones, what we need to do is to make this 0, to make this 0, as well as to make this 0. Say twice of row 2 and add that one with row 1 to be our new row 1. What happens? Okay, so we have 0 times 2 is still 0 plus 1. Okay, 1 is maintained. 2 times 1 is 2 plus negative 2. This becomes 0. 2 times 3 is 6 plus 3. This becomes 9. And 2 times 5 is 10. 10 plus 9, this becomes 19. We already have this to be 0. The next thing is to convert this to 0. Now, what we can do is we can use row 3, multiply row 3 by negative 3, and add it with row 2. So say negative 3 times 0 is 0 plus 0 is still 0. Negative 3 times 0 is 0 plus 1, it is still 1. Negative 3 times 1 is negative 3 plus 3 becomes 0. Negative 3 times 2 is negative 6. Negative 6 plus 5 is negative 1. So this will be the new second row. We still need to convert this to 0. So what we can do is we can choose to multiply row 3 by negative 9 and add it to the entries in row 1. So this becomes 0. So negative 9 times 0 is 0 plus 1 is 1. Negative 9 times 0 is 0 plus 0 is 0. Negative 9 times 1 is negative 9. Negative 9 plus 9 is 0. Negative 9 times 2 is negative 18. Negative 18 plus 19 is equivalent to 1. So notice that we were able to come up with reduced row echelon form. What do we have? We were able to convert the coefficient matrix such that the entries in the diagonal are only ones, and above that one and below and above that one are all zeros. Consequently, we can interpret the reduced row echelon form of the matrix in terms of the solution. So we will have here Z is equal to 2. We have Y is equivalent to negative 1. And we will have X equivalent to 1. Okay? So you have 1, negative 1, and